And the next presenter will be Sebastian Feige from Federal Office for Radiation Protection, Germany.
Thank you, Tuukka. Small space here. Okay. Thank you very much. Good morning. Okay, my presentation is about the quality infrastructure for Thoron. And the question is to be answered, is Thoron of concern or not? So yeah, already yesterday you heard something about Thoron from Feige, so I can skip some of my slides maybe. From the regulator point of view, it is extremely important to know, is it of concern? Do I need to consider it in the regulation or not? Are you aware that we are this year celebrating 125 years of discovery of radon and thoron? So just to mind you what happened in the early years, it was Rutherford in 1900. He discovered a radioactive substance emitted from a thorium ore. So that was thorium. And he, with this experimental setup, determined the half-life. So with 60 seconds, well, that's pretty good results at that time. And already a few months later, a similar experimental setup was used by Mr. Dawn in Germany, and he also discovered an emanation from a radioactive substance from a uranium ore, or from barium chloride, barium bromide. He also tried to determine the half-life of what he discovered and arrived at about 44 minutes. Well, that was not radon, but it was a half-life of summed up progeny. So, and I looked to my work package leader, Laureline. It was the French guy, Pierre Curie, who 2 years later characterized the half-life of radium, so exactly with what we use today, 3.8 days. That's a long time ago, but still, radon and thoron, it is in the environment. You heard already yesterday from Feige. There are two different isotopes. There are far more isotopes from radon, but we are talking about radon and thoron. Radon with a half-life of 3.8 days and thoron with 55 seconds. So due to that, the transport of thoron is rather limited. So only in a close distance to the source you can expect from thoron. It can be found in the soil gas, definitely. It is rarely found in the atmosphere, only in some areas. We heard it yesterday from the presentation from the FEM mine area. There are also some investigations about thoron in houses, but in most of the cases, the thoron gas itself, it is below the detection limit. So let's come to the risk of thoron. We have pretty good EPI studies for radon. So we have Darby study, we have Puma study, so that was yesterday already presented by Nova. But what is about thoron? There are no epidemiological studies for thoron. So the only thing, the only possibility that we recently have is we can use dose conversion, we use dose coefficients, and they are based on dosimetric models. So that underlines the importance of input parameters. If you use a dosimetric model, you have to use input parameters. Thoron seems to be negligible, but already in the 19th, we have some indications that in some situations we have higher thoron and also thoron progeny concentration in the dwellings. So let's have a look what to do. If we want to give an answer, is thoron of concern or not, we have to consider that at the beginning of this analysis there is metrology. So always in metrology is at the cradle of the protection. When we start with a model, with a dosimetric model, we have input data. We need to model, we have some observations. So we have to start with qualified data. The rest of the game is also known to everybody, so the observation, the modeling, it is transferred to scientific recommendations, to international requirements, and finally it ends up at the surveillance at a workplace or in the dwelling. And again, we need good data, good measurement data. If we are talking about the measurement, the metrology of radon and thoron, it is indispensable to know exactly what is your measurement. we are not talking anymore about radon gas or radon progeny or Thoron gas, but we need to talk about progenies. And the measurement for the progeny is potential alpha energy. This is pretty much known to you. So the potential alpha energy, it comes from the decay of the progenies. So the energy is transferred to your lung epithelium, to your respiratory tract, and you can calculate the corresponding alpha energy in an equilibrium between gas and progeny. This is well known. And if we compare the potential alpha energy for radon and Thoron, you will see that the potential alpha energy for the Thoron progenies, it is 14 times higher than the one of the radon progenies. Within the decay chain of Thoron, it is lead-212. That's a dominant radioisotope. So that contributes to your dose. So for protection against Thoron progeny, it is usually sufficient to focus to the intake of this decay product, lead-212. It is not a measurement, but already mentioned yesterday as well, there is an important equilibrium factor. The equilibrium factor describes the situation in an unknown composition of progenies in an air volume. So nobody is going to count the single isotopes in the air volume, except maybe the NMIs, Stefan does, to count the last scientific becquerel. But what we do is we calculate the potential, we measure the potential alpha energy concentration, and we put this in relation to a radon in equilibrium, so equilibrium equivalent concentration. And again, let's compare the situation for radon and Thoron. So with the equilibrium factor for radon, it works pretty good. So we have the possibility to measure radon gas and then to apply an equilibrium factor and to calculate the equivalent equilibrium concentration and the potential alpha energy concentration. F spans in a range, let's say 0.1 to 1, nearly 1. But it's not possible to do that with Thoron. Yeah? We have very, very, very low F usually. Only in the close distance, maybe to the wall, you can find the gas, so it is not a suitable factor for us. There's no equilibrium between Thoron gas and progenies in the air. The key in the metrology is always traceability. Again, for radon, that is solved. It is pretty much straightforward. We at BFS, we marry two measurements. We use the activity standard that we purchase someone from an NMI, and we transfer it to a known certified volume, and then we have a primary radon atmosphere. So pretty much straightforward. But what is about traceability of Thoron gas? You cannot purchase an activity standard of Thoron gas. So because of the half-life, it will decay rapidly. So what you need to use is you need to use a thorium emanation source put inside a small volume. We at BFS recently have the traceability with a reference instrument. That is a weak traceability chain recently in Europe. Yeah? We have one reference instrument that we calibrate, trace back by means of radon measurements. It was once calibrated as well, but we do recently miss an installation with real traceability for Thoron gas in Europe. So I'm not talking about only Germany, but in Europe. Please refer to our milestone report. We have a brief compilation of the existing metrological capabilities. And yeah, well, situation is not pretty well. Yeah, we have a lot of meteorological incests. Some institute calibrate and transfer to the next one, and they are all traced back to BFS. So that's not good situation. It was also mentioned yesterday that there are some challenges when measuring Thoron gas. For sure, but already since the Metro Radon project, it should be made clear to all the manufacturers that there is an influence of Thoron gas to radon measurements. And we should keep the responsibility with the manufacturers and to stress them, take care of this problem and comply with standards and make sure that you distinguish the radon and the Thoron gas. But we want to focus on progeny, not on gas. Traceability for progenies, in radon progenies, it is solved in the BFS by means of a reference source with a planar radium source that is in equilibrium with the progenies that is measured in a gamma spectrometer. Afterwards, we load a filter or a sieve with a high progeny activity, and in alternating way, we transfer the efficiency from the gamma spectrometer to our alpha spectrometer. All this is traced back to national standards, so also the calibrated flow meter. That's pretty much working well. For the measurement of progenies, I can just briefly introduce you again what is done when you measure progeny. Of course, you need a pump, you need a filter, you need a sieve to collect the progenies first. Now you can collect them, and after an equilibrium between sampling and decay, you can say, okay, now my collected alpha energy, it is proportional to the PADC. That does not work for the for the Thoron progenies, because there is no equilibrium, and the alpha activity on your filter, if you collect polonium-212, it's rather low. So you can see Thoron progeny in most of the cases if you sample radon progeny, but the activity is rather low. And the traceability for Thoron progenies is not given up to now. So that was one aim of our work in the radon norm project. Look at the milestone report. We did the theoretical consideration to design a reference field for Thoron progeny, and we followed different approaches together with Dick, together with GIG. Boguslav is here. So we at BFS follow the approach to adapt our PAEC traceability to the Thoron, and the GIG is working on using TLD and LSC with an absolute method to trace back the Thoron progeny concentration. Key in the calibration, key in the final use of instruments is calibration. So to close the traceability chain back to the national standard. Calibration means you operate an instrument under specified conditions. It is explained in standards like the STAR standard to operate a calibration facility with known conditions in the field. The question is, are these conditions meaningful? So what conditions shall we use to set up such an atmosphere? We think we should use the reference parameters from ICRP because they are the basis for the dosimetric model. So we will ensure that whenever we calibrate, we use such situations. By the way, the published data on the activity size distribution of Thoron progeny, they are rare. There are only limited number of such investigations, so we propose we should focus on that in the future as well to get more data. Okay, but now the vision for fostering good metrology for Thoron progeny is to include this measurement of the Thoron PAEC in the scope of an ISO accreditation. We are at BFS are accredited by ISO 70025, and we want to include this. And that was a good work in radionorm that we supported the installation of this chamber. It was not covered by the radionorm project, but we can today give you the good information that very soon we will have such a Thoron progeny reference chamber in Europe to calibrate the instruments. So it's no longer a vision, but we are close to have this chamber. So we started rather early before the radionorm project already, but with radionorm project we have a strong speed, so backwind from the project to work on the theoretical considerations, and we are here now between May and July. So in July the chamber will be ready, it will be commissioned at the BFS. So you see the pictures here, that was before, so just a few months ago. That's the situation now. In between we will have no PAEC calibration at the BFS. It's not possible because everything is disassembled and they are preparing to receive finally the chamber in Berlin. There's a lot of work, further work that needs to be done. We have to learn how does the chamber react when we change different conditions. Most important is to get a stable lead-212 atmosphere. That will take some days because of the half-life. I expect also we have some try and error. That's typically, we have scientific instrumentation there. So let's see what will happen if we change the position of the source, position of the fans, and so on. We also want to welcome researchers and metrologists in the future in Berlin. Let us work together also behind the radionorm project to continue working with this chamber. And finally, to include the Thoron DK products in the scope of the accreditation, but I expect this to start at the earliest in 2 years. Yeah. First, we need to learn about the chamber, and then, of course, we need to include this into the scope of our accreditation. Thank you for your attention, and I'm open to the discussion later on.